All right, welcome back, everybody. So we're going to do the second part. So we did one example where we took off this data and kind of analyzed it, and now we're back to the second one. So let's go ahead and have me share that screen. Hopefully this one will be a little bit quicker. Great. As my computer kind of gets caught up. All right, so there are two other examples in between. So I did the first example in your notes, and there are two more examples that you guys can practice. And now we're going to come back and do kind of the last one together. So this is a thermodynamic scientist that's observing two different variables, the x variable and the y. He did not really define them as what they are. So you're going to take this as this is the x, this is the y. So when we go into explaining, we're going to say this, as the x increases, the y will do whatever if we have to explain it. So starting off, I can look at this data if they ask me just to analyze the scatter plot. One thing, it looks like it's positive. All the dots look like they're going up. Two, this one does not look so linear. Now I know you see the black line, ignore that. But if I look at these dots, this does not look very linear. It looks like it's kind of curving. So I'm going to go non-linear. Now remember, when we look at the data a little bit more, it'll answer these questions a little bit more in depth. Let's see, so we go linear, oh, it looks pretty strong. I mean, these lines are looking like they're following a pattern together. They're kind of looking like they're close together. They're not really spread out, so it's really difficult to see anything. And then the last thing, of course, is do we have any outliers or any kind of clustering, anything like that? And I do not see any of that. So if I'm asked to analyze just the scatter plot, just the dots, these are the four things I can kind of say about it. After that, I'm going to look for more data. That's going to be coming off this residual. So once I see the residual, I can clearly see that these are not evenly distributed. They're kind of following this like little kind of curve that's kind of going up and down, kind of a sine curve for those of you guys who know what that is, or cosine curve. So either way, is this data going to be appropriate? No. This is not appropriate. These dots should be evenly distributed in order for it to be a line. So the data that we got off the calculator, all that big long line of stuff that we have on the paper, this table of values, none of it's technically relevant because this table of values is about a line. It's a linear regression. And I don't have a linear regression. This is not a line. It shouldn't be a line. So you're going to see that this, when I answer it, I can still answer some questions off the table, but you're going to see whenever they ask me, I'm going to say it's not good. It's not a good fit for analyzing, or I can't analyze because this data doesn't work. So again, this doesn't work. No, this is not a good fit because for me, the residual plot kind of curves. It's not evenly distributed. So that's what the residual plot does, is it tells us whether a line is a good fit or not. So I am correct here. When I looked at the scatter plot and said it was nonlinear, yeah, you're right, it is nonlinear, which means all this other stuff I can't really do. So let's kind of jump to those. How do I answer that? Find the correlation. Well, I can tell you what the correlation value is. That's my R value. But I can't analyze it. So I can tell you if they ask me what's the correlation value, well, it's 0.839 Normally I would say, oh, it's positive, it's fairly strong. But in this case, what does it mean? Well, I can't analyze it. This table's all bad because it's not supposed to be a line. So I'm just going to say not a good fit. To analyze. Meaning I can't do anything. So don't ask me about the data and it relating. I can tell you what the correlation is on my table, but based on my graph, I shouldn't be using this information. This is for a line and I don't have a line. All right, write the equation. Well, I can write an equation. Again, it's still not a good fit. No, I will not be using it. But I turn around and I go, okay, well, I have my, according to this, I have my A value. So I got 27.8245. I go over and get my B value. He's positive, so I'll put a plus, and then 0.9 58393. So you can see, like, we could still write it. The calculator is always going to give me information, but it's still not a good fit. So you're going to be saying this a lot. This table is not a good fit. This line shouldn't exist. All right. What does the slope mean? Well, again, not a good fit. I can't tell you what the slope means. So whenever they ask me to analyze anything further than just telling you what the number is, I'm going to say not a good fit the whole time. So what's the y-intercept? Ooh, once again, not a good fit. Or I'll say I can't analyze because it shouldn't be a line. Again, what is the standard deviation? Well, I can tell you what it is. Again, that's this one, that's the S. It'll give me a value. It's 12.3375. But the minute it says, now tell me what it means or any of that stuff, it's not a good fit. I can't answer any analyzing questions because I shouldn't be using a line. And this table is all about lines. That's the information that we will be given. So same with the last thing, what's the coefficient of determination? Well, that's my R squared. I can tell you what it is, but when you ask me to analyze it, I'm going to once again say not a good fit. So that's kind of the last part of this. So the nice thing is, if it's nonlinear, these analyzing questions become very, very easy because the only thing that you guys have is this information. Now, yes, there is another way to program nonlinear information, but everything that we do in this class, we're going to be looking at linear information. So if we come against something that's nonlinear, we're just going to say it's bad. I can't analyze. I can't tell you anything. I mean, I can tell you what the numbers are because you've given me numbers, but they mean nothing to me. All right. I hope this helps. And good luck. You guys have a quiz right after this. So wishing you luck on it. Thanks. Bye.